Hello, welcome to the free response question of the day. Hope you're doing well. And so this is the 2007 number 2. I think this sort of type of problem is likely to be on the exam this year. So let's see if you can figure this one out. So this one says, as dogs age, diminished joint and hip health may lead to joint pain and thus reduce the dog's activity level. Such a reduction in activity can lead to other health issues such as weight gain and lethargy due to lack of exercise. A study is to be conducted to see which of two dietary supplements, glucosamine or chondroitin, is more effective in promoting joint and hip health and reducing the onset of canine osteoarthritis. Researchers will randomly select a total of 300 dogs from 10 different large veterinary practices around the country. All of the dogs are more than 6 years old and their owners have given consent to participate in the study. Changes in joint and hip health will be evaluated after 6 months of the treatment. Part A, what would be an advantage of adding a control group in the design of this study? Part B, adding a control group or assuming a control group is added to the other two groups in the study. Explain how you would assign the 300 dogs to the three groups for a completely randomized design. And then part C, rather than using a completely randomized design, one group of researchers proposes blocking on clinics and another group of researchers proposes blocking on breed of dog. How would you decide which one of these two variables to use as a blocking variable? So if you want to pause this video and give that a shot, that would be great. Okay, part A, what would the advantage of using a control group? Well, that gives us a comparison, a baseline group that helps take into account other variables. So what we've got here in this experiment, we've got two drugs. They're comparing glucosamine and chondroitin. So they initially just have those two groups. Well, so in the results of that design, they can only pair the effects of the two drugs. They can't compare it to no treatment at all, okay? And that's what a control group is for. So a control group gives us a baseline comparison to see the effectiveness of the drugs relative to no treatment, okay? Because there could have been other variables going on. There may be other variables going on during the study that could affect the joint and hip health of the dogs. The control group allows us to see the effects of these variables. The key thing here is you're saying that the control group gives you another comparison group, and you're saying it in context. You have to mention that. You have to mention the joint and hip health. That's it's very important to mention the context in every one of these answers. Which the big thing we're interested in here is the improvement in the joint and hip health. And so there you go. And then part B, it says, how would you randomly assign the 300 dogs to the three groups? Okay, so here we go. There's kind of different ways you could do this, but here we go. So you would assign each of the 300 dogs a unique integer from 1 to 300 using a random number generator. Create 100 unique integers. You have to say unique or distinct or ignoring repeats from 1 to 300. The 100 dogs with these integers go into groups that taste the glucosamine for 6 months. So you have to say it's the dogs, not the numbers. It's the dogs that's going into the groups. Okay. Use the random number generator to create 100 more unique integers, ignoring any repeats from the first 100. We can't have the same dog get two treatments. All right. The 100 dogs with these integers receive the chondroitin for 6 months, and then the remaining 100 dogs are the control group and get no drugs. There you go. So when you're randomly assigning, you have to clearly state how you're numbering the population. Use a random number generator to generate whatever number you need from the total. Okay, and then clearly state it is the dogs or the people or the cats or the trees or whatever you're working with. In this case, dogs. Clearly state that it's the dog that's going into the groups. Now, and this one just asks us to talk about how we would randomly assign. If you were doing the whole experimental design, you would then say compare the improvement in joint and hip health between the three groups. Okay, that was the only thing that needs to be said to make it a complete experiment. All right, and so then we have part C. Rather than using a randomized design, they're talking about blocking, and they're talking about possibly blocking on the clinics or blocking on the breed of dog. Which one would you choose and why? The variable that you choose to block on is the one that is most different in regards to the response, in regards to the context. Which one do we think is going to have the biggest effect on the improvement in joint and hip health? I would think breed of dog. Now, as long as you made a solid argument where you stated, well, you pick a variable that's going to be where the different groups are going to be more different, okay, than other groups. I think that like large dogs could have a different joint and hip health improvement than small dogs. Whereas clinics are going to be heterogeneous. They're going to have, some small dogs, some big dogs, and so forth. And so they will be like heterogeneous. So this is the way that I would describe this answer. I would block on the variable that I believe is the most different in the changes in joint and hip health. Mention the context. Mention the response. I think this would be breed of dog, as different sizes of dog could have varying joint and hip health improvement. Clinics should have a wide variety of dogs and be heterogeneous as far as response in joint and hip health improvement. The proper blocking on breed would result in less variability in joint and hip health improvements. So there you go. And if you have any questions about that, let me know. I hope you're doing well. I miss seeing y'all, and I look forward to seeing y'all again sometime soon in the future. And that's it for today.